This section is called rectangular coordinate and graph. However, we're really in this section only going to be looking at the distance formula and the midpoint formulas. So I'm not really going to be concerned that you can graph on a coordinate plane. I'm assuming you can already do that, like know where coordinate points are and be able to graph them. So we're going to skip that part and just jump right into the distance formula and the midpoint formula. So let's do this thing. All right, so let's talk about distance here for a minute with our distance formula. If we have our distance formula, which is d is equal to the square root of x2 minus x1, the quantity squared, plus a y2 minus y1, that's a minus, the quantity squared. Now, check this out. That x2 and x1 are subscripts, which means that I'm actually finding the distance between 2 points. So, I have my first point of x1, y1, and I have my second point, maybe put a little 2 in there, of x2, y2. Now, here's the deal whenever it comes to these problems. It doesn't matter which point you put first, as long as your first point that you have on your paper is the same. So as long as this is an x2 and a y2, that's all that counts. It could very well be an x1 and a y1. These points are arbitrary of which one you do first. So your distance formula could equivocally, that's a big word for a math person, equivocally be x1 minus x2 squared plus a y1 minus y2 squared. So I want to make that point of you don't specifically have to go with the second point listed and the first point listed. You just have to make sure that whichever one you put first is the first y value. If you put this as second, then that is your second y value. All right? Cool. Let's do some examples. Okay, our first example here is just going to be simply finding the distance. We got a point P and we got a point Q. We're going to find the distance between those 2 points. Now again, I want to reiterate the concept that this can be x1, y1, and x2, y2, and it does not matter which order they go in. So when you're looking at these problems, because I read left to right, I like to start with point P and go with point Q secondly. That helps keep me organized because remember, 98% of success in mathematics is what? Organization. All right. So I'm going to square root and I'm going to take my first x and I have negative 8 minus, and I take my second x here of 3 and square that. Then I'm going to look at my y's because I started with negative 8. I'm going to have a 4 to begin with and then minus a negative 2 and then that is going to be squared. Oh, I almost forgot my second set of parentheses. Cool. Okay, look, if you minus a negative, that's the same thing as plus, right? So what I really have here is the distance of the square root of negative 11 squared plus a 6 squared. Now what happens when you square a negative number? It becomes positive, right? Cool. So my distance is actually equal to 121 because that's 11 squared plus 36. Add it up. Your distance is now equal to the square root of 157. Now if you can break down that square root, you need to, but if you can't, you leave it, such as in this instance. Now notice, I am subtracting in my parentheses. So whenever I'm looking inside my parentheses, I am subtracting that. Why then do I have a positive number here if I have a negative number there? Yeah, because when you square something, it makes it positive. So here's the deal, and pay attention to this one. Anytime you have a number under a radical, it has to be positive. And we also know that distance is positive. There's no way to have a complex number. You're not looking at anything imaginary there. If you have something imaginary, it means you screwed up your parentheses. So make sure you are keeping your parentheses and then square that. That will always end up being a positive number, even if you have a negative within the parentheses. All right? It's kind of a big deal, so make sure you pay attention to that.